Let's continue with our ideas about how we should look at chemicals and compounds in particular. Now, I've called this one naming inorganic compounds, and that means we're talking about metals and non-metals. If we're talking about organic compounds, we're going to be talking about carbon compounds like hydrocarbons and many fuels that we actually burn in our daily lives. And this one, they each have different rules. And I think there's another short video of mine on the naming rules that apply to organic or carbon-based compounds, but that we can sort out later on anyway. But it's important that we realise that chemicals like us have two names, and the names are based upon the parts that make them up. So if we've got a metal part and a non-metal part, then both the metal and the non-metal contribute to the overall name. And like us, they've got two parts of their name, but when scientists were making up a rule, they decided that every time the first part would be the metal name. So the metal name is always first, and the non-metal part is always second. Now that makes it nice and simple for us, and that's regardless of which chemicals we're talking about. Now later on you might see that we can have a metal and a complex ion, and the same rules actually apply. The metal part is named first and the complex ion name is named as second. So it's nice and simple if we follow this. So in other words, metal bits are always named first. So that brings us to the question, what is metal and what is a non-metal? Now we know that metals and non-metals have opposite properties. We learnt that in previous years' science. With us it was in year 8. And we know that we can find this on the periodic table. So what I've got here is a blank periodic table which I've just added a bit of colour to. We can see that the clear boxes, or the white boxes, are metals, and they constitute the majority of the periodic table and the elements that make up the periodic table. So all of the ones on the left-hand side of the table in the white are metals, and we see where the boundary layer lies on the right-hand side, and it forms a step-like structure as we go down. So all the things in orange are non-metals, so all this pile here are non-metals, and all this pile, including these ones down the bottom, are metals. And that means they have the properties that go with metals, and this means that these ones have the properties that go with non-metals. And I know we've done it before, but on the boundary layer there are these elements either side of the boundary layer, and they tend to be a little bit mixed up. They can't decide whether they want to be a metal or a non-metal, so some people call them metalloids, or we can call them semi-metals. I think metalloids is probably the easiest one for us to remember. So one of the experiments we've done was to burn magnesium in air, and of course we know that we have to avert our eyes to it. It's very much like a welder's flash, and we can get an after image on our retina. If we're not careful, we can actually even cause our retina to start to peel away from the inside of the eye, which is not a good idea. We see that a lot of energy comes out, and we know that a chemical change has occurred because of this. And we also see there is a change of colour and a change of structure. We go from a solid, shiny metal and a transparent gas and end up with a powder. So let's think about naming this compound we're going to make. So obviously we're combining the elements magnesium, and we see magnesium is right across here on the left-hand side, so that makes it the metal. And oxygen's across here on the right-hand side, which makes it a non-metal. Now remember, the boundary goes here. I've added the names for all the elements now, or rather the symbols for all the elements on the way through. And we can see that we've got the metal and non-metal parts. So obviously, when we name our compound, we name it magnesium, which is the metal bit. And notice we don't call it magnesium oxygen. We call it magnesium oxide. So if we name a metal and a non-metal, and they're both elements, then the non-metal name is shortened and always ends up in IDE. So oxygen becomes oxide, chlorine becomes chloride, fluorine becomes fluoride, nitrogen becomes nitride, carbon becomes carbide. So all these things go through and we form a nice little pattern. And by the way, this is our magnesium oxide. See how it's not shiny anymore? It looks more powdery. If we touch it, it breaks into a powder and it forms this lovely structure. So magnesium oxide is our name. And I'd like to say this, that the name of the metal part remains unchanged. So the metal part is always called magnesium, or whichever metal is being used. The name of the non-metal part is shortened and IDE added. Now earlier on I talked about the fact that we also have the same sort of rules for complex ions. So if we had magnesium reacting with, say, sulfate, we don't change. The only difference this time is we do not change the name of the complex ion. We simply add the metal name first, magnesium, and then we add the complex ion name to it, which is sulfate. Now, even though the formula might have numbers in it to show the ratio of the elements to the complex ion, we don't talk about those numbers in our naming. So the numbers are disregarded. So there might be 3 oxygens and 2 metal bits. It doesn't matter. We just call it the metal oxide. Okay, and that's a good starting point for us to work with.